Hi, my name is Laurel Rouse, and today I'll be talking to you about a spreadsheet that I made for sizing anaerobic digesters in developing countries. It's based on literature review and values that I've found in literature review. There are approximately 5 user inputs, and I'm going to go through those. Then the outputs, it will tell you how large your digester needs to be, and then based on based on which three types of digesters the user chooses, it will tell you the dimensions of that digester that need to be met for that volume. So I'll start out giving a little overview of the inputs into the model. I'll tell a little bit about the outputs that are given in the third page of the spreadsheet, and then I'll go through a little bit of explanation on the second page, which is the internal model calculations. And I won't go through with a fine-tooth comb. There's a lot that's involved, but I'll kind of give an overview of that. This is the user input page of the first page of the spreadsheet. And the user needs to input 5 things. The first is what type or types of animal will you collect manure from. There are 5 different choices, and granted there are more animals you could collect manure for, but these are the ones that I had information on, so those are the ones that I chose for the spreadsheet. The first is a gestating sow swine. It's a mother pig who's suckling. The second is a swine boar, and the third is a poultry. Fourth is cattle beef, and the fifth is cattle dairy cow. And the reason for the different swine and the different cattle choices is because the manure that they produce are different volumes and different characteristics. So for this first input, the user needs to, for the coding of the spreadsheet, the user needs to put it in the order that I have it listed here. So for example, I set 1 equal to the swine gestating sow, down to 5 equal to the cattle dairy cow. And you need to put, for example, if you have a swine gestating sow, you need to put a 1 in this answer 1 box. It will not work if you put a 1 in a different answer box because of the way that the coding was done. So say right now it's 1, 2, 3, 4, 5. That's for all 5 types. Say I only have a swine boar and a cattle beef. Then I would leave the other ones blank. You don't want to put a 0, you just want to leave it blank. So we'll do blank in the first box, 2 in the second box, blank in the third box. We'll put a 4 in the fourth box, and then blank in the fifth box. Moving on to the second question, how many animals of each answer type are there? So for this one, you need to make sure that your answer 2 box matches, well, you need to make sure that if you have a swine boar, you put a number here, but you don't put a number in the ones that you don't have. So I'm going to take, I had 1 of each previously, but now I'm going to take the 1 out of the answer 1 box, and I'm going to say that I have 2 boars instead of 1. I have 2. For the third answer, I didn't have any poultry, so I leave this blank. You don't want to put 0, but blank. And then I'll do 1 beef cattle, and I need to change this to a blank as well. So that's answer number 2. And input number 3 for the user is, what is the approximate mean temperature during the warmest 6 months of the year where the digester will be built? So your answer A, it has to be in Celsius, and you can base it upon, looking up weather data for the area, or it could just be approximate. So I chose 35 for the warm temperature. And what is the mean temperature during the coldest 6 months of the year where the digester will be built? I chose 31 degrees Celsius for the colder 6 months. This would be, somewhere tropical that's pretty warm all year round. What type of digester are you building is the 4th question. And there are 3 types that I chose. They're the polyethylene tubular digester, the fixed dome digester, and the floating drum digester. The polyethylene tube digester is basically made out of polyethylene plastic. It's like a round tube that you put a pipe into both ends, and you can find more information about building one of those elsewhere, but for the purposes of this, it's just, one of the types. The fixed dome, which is a fixed volume digester that's usually built out of bricks and usually built into the ground. The 3rd type is a floating drum digester, which is usually built out of cement, but that cement is coated and then has a steel top to it, so it's an expandable volume digester. And you see these different types in different areas of the world. So it can also be based on where you're working. If you're not working in a place that has floating drum anaerobic digesters, you probably don't want to build one, because you won't be able to get the parts to fix it. The one that's missing here is a repurposed plastic container, which I think would be a good type for a small household size, but it's not in here just for the purposes of the spreadsheet. For the 5th question, it's what are the arrangements of the livestock? So there's 3 options that the user can choose, and this is based on how much manure it's estimated that could be collected during the year, because if the livestock are ranging, the manure will be very difficult to collect and labor intensive to collect. So the first option the user can choose is that the livestock are free ranging during the day and penned at night. The second option is the livestock are free ranging during half the year and penned during half the year. And the third option is that livestock are penned all the time. So that's just going to tell the model approximately how much % of the manure produced will be collected. Now I'll be talking about the 3rd sheet on the spreadsheet, which is model outputs, and then I'll go back to the 2nd after this. These are the final outputs that are given to the user to use in sizing the digester. So what we're given is based on the user inputs and all the calculations in the intermediate. The user is told how many meters cubed of biogas per day is produced based on the animals and the number of animals that they put in. And this number, 0.85 meters cubed of biogas per day, is from a literature value for one household in India. So it's just to give you an idea, you're producing 0.5 meters cubed of biogas per day, but it's less than one household would use. So you're going to need to supplement your gas needs based on that. And this this number, the 0.85, I'm not sure how accurate it is, but it was supposed to be based on cooking 3 meals per day for a family, so 5 people. Next, it gives I'm going to jump down here to the manure addition. The spreadsheet assumes an organic loading rate of 1 kilogram of volatile solids per meter cubed per day, and that's based on reading literature and based on the fact that these are not going to be heated and not going to be mixed. So it's much lower than it would be if you did have heating and mixing in your digester. So we assume a 1 kilogram volatile solid per meter cube per day always as the ORL. So based on that, no matter whether you're sizing a digester for the cold temperature or whether you're sizing it for the warm temperature, you will have the same manure addition and water addition because you're keeping the organic loading rate the same. So the first line here, it says manure, volume of manure that's added. So this is in a liters per day or a kilograms per day basis. The literature paper that I found assumed that the density of the manure was the same as the density of water, which is not quite true, but that's the assumption that they made, so I carried that over to my model. It'll give you also the volume of water that you need to add along with that manure on a liter per day basis. And then you can come up here, it will tell you your volume of reactor vessel for the cold season. This is going to be larger than your volume of reactor vessel for the warm season. And that's because the solids retention time is different. Based on the internal calculations, the SRT for this particular one, and again, this is all based on what the cold temperature the user put in, the SRT for this one would be 25 days. And then for the warm season, the SRT would be 20 days. So it's got a shorter SRT, you need less volume available to have your solids retention time, that smaller number. So usually you would size your reactor based on the cold temperature. However, if you wanted to, for some reason, you could size it on the warm season. And that could reduce costs, or there could be advantages for that. The type of digester. The next is the type of the digester, and this field here will change depending on what the user inputs. So here the user inputted that they wanted to have the floating drum type of anaerobic digester, and it will tell the diameter of that vessel and the height. That's based on a ratio of height to diameter that was found in literature, and it will also tell you if you need an external gas storage vessel, what the volume of that needs to be. And for this particular type, the floating drum, because it expands in the volume, you don't need an external gas storage. So that's what the model will tell you. This is for sizing a particular type of gas storage vessel. That's the polyethylene tube type, and that's made out of the same material as the polyethylene digester is made out of. It will tell you the diameter and the length for that storage vessel. And in this case, again, we say there's no external gas storage required.